So understanding which bits of our code process that unauthenticated attack surface is going to be important. How could that risk be exploited, and what are, the different parts of that? So when we look through the code, we'll find that low-level packet handling routines would be bad to have a bug in, right? That would be really bad because then an unauthenticated user might be able to exploit our service based on that. Anything in the identification exchange, the session setup, compression handling, authentication, privilege separation issues, authentication files, external application invocation. So any parts of our server, if we have flaws in any bits of these, that's going to be really bad for us. So it's good to identify right up front, hey, these are the critical attack surfaces. Let's spend the bulk of our time there. It makes sense. That's where we want to focus. So we could start by looking at the program either from a high or low level. Let's start from the low level analysis first, and then we'll talk about the high level. And consider kind of the viability of each bug class to start with. So for example, integer errors. If you look at the way they're using integers, are they using all unsigned integers in a consistent way? And if they are, that's a good thing. If they're mixing signed and lengths of different integers, and we'll talk about this in a later class, there's some real issues that can come in from that. Okay, buffer overflows. That's one of the most traditional problems in C and C++ programs. Is there a consistent way that they copy data into buffers? Is there a consistent way that they allocate and deallocate buffers? That's going to be really important to take a look at. And there's lots of other, bug classes as well. Format strings is one that we'll, again, talk about in another class. That bug has largely been taken care of with static analysis because it's pretty easy to find. It's basically where you don't specify a type in a format string, which can lead to some pretty bad problems if it's not done, but it's pretty easy to find statically, so a lot of those types of bugs have been removed in code bases now. So once you've considered those type of lower level memory corruption, it's time to think about more of the design and also the state of the program and objects. For example, use after free or double free, these have been big issues across C and C++. And again, this is where you need your auditor to be an expert on the language that he's auditing here. So is there a code path where, in the fatal function, for example, you might free a buffer and then in the cleanup it might get freed again? Is there some way that we can force an object into an inconsistent state? Knowing that these type of issues have been problems in the past leads us to want to take a close look at those. Okay, so now let's take a look at what some of the high-level attack vectors might be. And most of them are pretty common sense things like, is sniffing a problem? It shouldn't be because we have the encryption. That's the whole point of SSH. Is there a way that an attacker can man in the middle a connection? Which means to force a client to connect to me as the attacker, and then I forward the connection onto the real server, and I'm sitting in the middle so I get to decrypt all the traffic even though it's encrypted. Are there some other protocol quirks that maybe weren't documented well or were implemented incorrectly? Those are the types of things we're going to be looking for. Also, when it comes to the login, let's think about brute forcing, multi-stage authentication, disabled accounts, file-based authentication, incorrectly set up and functioning authentication. So anything that deals with logging in that might allow an attacker to, kind of force his way into a server when he shouldn't be able to is going to be very critical. And again, these things are probably more design, kind of higher level issues than they are specific to, like, say, a buffer overflow or something. So all that's left now would be to actually go through the code slowly and carefully and do all those activities, which I'll save for another lab.